At first glance, you might not think that this 5th anniversary image from NASA's Spitzer Space Telescope would actually tell us anything about our own sun or Earth. But astronomers see this region known as W5 differently. Its strangely chaotic dust structures are like a work of art. But to astronomers, W5 is more than just a picture. It's a graphic novel, telling a story of how one generation of stars is helping the next to be born. While it's filled with thousands of average-sized stars, it's the dozen or so stellar giants that are really calling the shots. Compared to our own G-type sun, these enormous O-stars have about 30 times as much mass. Moreover, they're about 10,000 times as luminous, and most of that light is in the ultraviolet. Yes, we are talking instant sunburn.
So the radiation that these O-stars put out, vast amounts of ultraviolet radiation, has a very destructive effect. It breaks up molecules and it destroys dust grains. And the stellar winds, these very violent, energetic stellar winds, sweep up material around that creates these large bubble structures that we see, these very large cavities around them.
However, denser areas take longer to clear, lingering as the material around them is swept away by the radiation and stellar winds. This sculpts distinctive pillars that, like accusing fingers, point out the stars that created them.
We're pretty sure that dense clumps of gas are likely to collapse under their own gravity, and that's how we think stars form. But if you give them a little push, like the O-stars can, with the energy that they're putting out and the expansion of these bubbles, the stellar winds they're blowing past, this can help the work that gravity is doing in collapsing these clumps down.
We can see some of these baby stars inside the dense tips of many of the pillars.
In W5, we think we can trace 2 or 3 generations of star formation, starting near the center of the big cavity, where there is an O-star, which probably represents the first generation of star formation, and then working outward to young stars that are found inside this big cavity, and then further out to stars that are just now forming in the molecular gas on the rim of the bubble.
This kind of study would not be possible in visible light. Only infrared images can pierce the veil of dust to show the interesting bits. Some of those young stars appear to be shedding their surrounding material before our very eyes. At 24 microns, seen in red, a number of smaller stars have dust tails pointing away from the nearby O-stars. These dust tails indicate ongoing destruction of protoplanetary disks by stellar winds. Indeed, stars unfortunate enough to form too close to an O-star could well be stripped bare before having any time to form planets at all. W5 shows us how interconnected things can be in our own galaxy. Stars are born, reshape the nebula around them, and give rise to the next generation of stars. Perhaps 5 billion years ago, some long-gone O-star swept up the material that formed our own sun. And if it had been a little too close, perhaps our own Earth would have never formed, and we would have never evolved here to look up and wonder why.
The Hidden Universe is produced by the Spitzer Science Center at the California Institute of Technology.